Okay, so they have the number 24, and they're going to divide it into two parts. So I'm going to say the two parts are going to be x, and the other part would be 24 minus x. So that's two parts. If you add those two numbers, you get 24. Then they say, such that twice the square of the greater. Well, if this is the case, I need to label one as being the greater and one being the smaller. I'm going to say this one over here is the greater part, and this one over here is a smaller part. All right, it's important you understand that we're talking about two numbers that add up to 24, and one's a small guy, one's a large guy. All right, so what did they say? You're going to break 24 into two parts such that twice the square of the greater that's twice the square of the greater, shall exceed 5 times the square of the less by 45. Well, there's your goal. And you've accomplished it. You wrote down what they said. What am I going to do now? Solve the equation. And looking at it, well, let's go through it. It's work. So you get 2, 24. Whoops, that doesn't look like 24, does it? 24 squared minus 48x plus x squared equals 5x squared plus 45. Well, let's see what you get. And I'm gonna start doing things, one at a time, and I'm gonna take care of the x squareds. And it's gonna be 5x squared minus 2x squared, which is 3x squared. All right? And then I get, that's minus 96, so plus 96. Now the number's a little peculiar, but I'm gonna write it down for you. It's gonna be actually 45 minus 2 times 24 squared. I have to do that arithmetic, by the way. And before I do that, I want to point out, I want to make it a little bit easier for me. And what I'm going to do is divide both sides by 3. So I get 0. I get x squared. I get 32x plus 15 minus 2. Well, remember I got 24 times 24. And 24 times 24, if I divide by 3, it's going to be 8 times 24. All right? And sometimes you still have to do the arithmetic. You're right. I still have to do it. And let's do that now. So we get x squared plus 32x. I'm going to get my eraser out. Erase my arithmetic over here. And I got to do something over here. So I got 15. Whoops. Minus 2 times 8 times 24. Again, I can do something strange. I'm going to factor a 3 out, and I get 5 minus 2 times 8 times 8. And then I get 3, 5 times, 8 times 8 is 64. 2 times 64 is 128. And what do you get over there? You get 3 times minus 123. All right? I'm done with that. And what do you get over there? Well, it's going to be minus 369. You get my eraser out, and yeah, it's work. I know that. I realize some students are going to, can I use the quadratic formula? Can I do this? You can do what you need, and I really mean that. You might look at what I'm doing and be frustrated by it, but you want to work on this. It's not so much me working on it. So x squared, whoops, I want to factor it. I don't want to do that. Let's put this down, and I'll put this over here. And x, there's not much choice in that. And I'm looking at it, and 369, right? I'm going to put this on the side for you. And that's going to be 3 times 123. Oh boy, that's a tough one, huh? 123 is also divided by 3, so I'll put this over here. 9 times 41. Well, you don't notice 9 and 41 differ by 32. So let's write that down. 9 and 41. And what do you get there? Plus 41 minus 9. All right. Now, you might forget why you've done this. You've done this because you're getting numbers. What numbers do I get? X equals 9. Or x equals minus 41. All right? So what I'm going to do, claim over here, I just want to get rid of all my work now, right? This is in the past for me. Everything is in the past for me. And what I want to do, it's almost like I'm studying for an exam. I want to know, did I get to where they got? I'm not saying answer the question yet, but let's just look at the nice, neat answer key. You know, I said X was a smaller part. I said this. I went through a bunch of work over here. I eventually get this over here. And let's see. Well, you know what? I do see they got the, you know, looking at this over here, let me put it by this. The answer would be minus 41, and the other one would be 9. All right? And then the question becomes is, I got to go back and read it. I wonder what their question is. I do see their answer, by the way, but I want to see what the question is. It says divide 24 into 2 parts. Well, the 2 parts could be, if I chose 9, 9 would be the smaller guy. And what would the larger guy be? Let's put that down. The larger guy would be, what, 15 then, right? Again, 9 is the smaller part, 15 is the larger part. Let's do the other one. Minus 41. Doesn't seem to make much sense, though, does it? And then what? It's like dividing a number into 2 parts, and you just get a negative part and a positive part. I'm not saying it's wrong, though. Don't get me wrong over there. It's 24, so that would be 65 then, right? Yeah, and this is a small part and a larger part. I do want to point out that when Wells speaks about a number, that they're really using it in a traditional sense. Like if you said someone to, you know, could you give me a number? I don't think they say minus 41. I'm not saying it's wrong, by the way, but the answer here, I'm going to say in context of the language, 9 and 15 would be appropriate. However, this also works. And why is that? If I divided 24 into 2 parts, I could say, oh, the 2 parts are minus 41 and 55 because they do sum to 24. And I could also go on to say, you know, twice the square of 65 is equal to 5 times the square of minus 41 plus 45. All right? But again, Wells, kind of a stickler on the language that's used commonly, and the 9 and 15 would make most sense to Wells over here. All right? But again, these things also work out well too. All right? Thank you.